Scalars and vectors. Scalar is a quantity which has magnitude only. On the other hand, a vector will not only have the magnitude but also the direction. Now I am going to present you a table in which there are a lot of parameters and we need to figure out which parameter out of these is a scalar or a vector. All we need to focus on is these two conditions. So let's start with volume. Volume only has a magnitude. It does not have any direction. That is why volume is a scalar quantity. Similarly, density also is a scalar quantity as it does not have any direction. But velocity, on the other hand, is a vector quantity. Velocity is not only going to have a magnitude, but velocities of objects always are in a specific direction. Speed, on the other hand, will be a scalar quantity. Speed is nothing but the magnitude of velocity. Pressure, mass, and temperature, all these three parameters are scalar as they only have magnitude. They do not have any direction. But momentum is the product of mass and velocity. So even though mass is a scalar quantity, as I have mentioned here, but velocity is a vector quantity. So whenever you are multiplying a scalar with a vector, the resultant will be a vector. So momentum, which is the product of m and v, momentum is considered as a vector quantity. Next off, we have force. Force definitely is a vector quantity as it has magnitude as well as direction. And finally, we consider current. That is the most trickiest parameter to handle. Is this a scalar quantity or a vector quantity? Now, a lot of students think that current is a vector quantity because it has a direction. So look at this diagram where I have shown this wire, and in this wire a current of 2 amperes is being passed. So 2 amperes is the magnitude and direction has been represented by this arrow. Now, since the current is having a magnitude as well as direction, this does not mean that this is a vector quantity, because let's go back to the condition. A quantity having magnitude as well as direction, this is the first condition which needs to be satisfied for a parameter to be called a vector. There is another condition. If a parameter is truly a vector, then it is going to satisfy something called the law of vector addition. Let us understand this in a lot of detail. Consider we have an object on which two forces are being applied, a 6 Newton force and a 4 Newton force. But you can see the two forces are parallel. And if the question asks us, what is the total force, what is the resultant or the net force acting on this object, we will add the two, 6 plus 4. So we will get the net force as 10 Newtons. On the other hand, if we consider the same two forces, but they are acting in the opposite direction, so theta is 180. In this case, whenever the two vectors are opposite, then we subtract. So we'll do 6 minus 4, which means the net force in this case will be 2 newtons. So let's consider theta is the angle between the two vectors. So in the first case, the angle was 0 degrees and the net force was 10 newtons. In the second case, where we subtracted, the angle was 180 and the net force was 2 newtons. So if you observe carefully, the resultant, the net force is different dependent on the angle. And that is what the law of vector addition states. Resultant of vectors depends on the angle between the two vectors. Consider one more example here. When the two forces are acting at an angle theta, now this angle is neither 0 nor 180. In this case, the net force will neither be 10 newtons nor 2 newtons. And consider the last example when the 4 and 6 Newton force are perpendicular. Even in this case, the resultant force will be different. So if we keep changing the angles, the resultant, the net force will keep on changing. And that is why I mentioned for a parameter to be considered a vector, this condition needs to be satisfied. Now coming back to the question, current, is it a scalar quantity or a vector quantity? Let us understand this with an example. Consider two wires which are intersecting at a particular point. Let's consider this intersection point as the junction. So the two incoming wires have 2 amperes current each, and the two wires are kept at an angle theta. Now, the total current in the outgoing wire is always the sum of the incoming current. So 2 amperes and 2 amperes when added will give us 4 amperes. On the other hand, let us consider the same situation, same two wires, but let's consider the angle is greater. So let's look at the same diagram. It is the same situation. The only difference is theta. This angle is much greater than in the previous case. So in this case, what will be the current in the outgoing wire? In this case also, the total current will be 2 plus 2, which is 4 amperes. So the logic for current is resultant current is always the addition of incoming currents, and it does not depend on the angle theta between the incoming wires. The resultant current will always be 4 amperes if the incoming wires are 2 amperes and 2 amperes. And that is why we say current is a scalar quantity. It is not a vector quantity because it does not satisfy that condition, which is the resultant of vectors depends on the angle between the two vectors. And coming back to the table, now we can say the current is a scalar quantity because it is not satisfying the law of vector addition. All right, back to the law of vector addition. We had considered these two situations. Initially, the angle was 0 degrees when the two forces were acting in the same direction, 180 degrees when the forces are opposite. Now consider the situation 3, when the angle between the two forces is 90 degrees, which means the force is perpendicular. Which means the forces are perpendicular. In this case, how do we figure out the resultant force? This is where we need to understand something called the parallelogram law of vector addition. Using this law, we will be able to figure out the resultant force when the angle is neither 0 nor 180 degrees. So how do we do that? The two forces 4 and 6 are perpendicular to each other. The two forces 4 and 6 are perpendicular to each other. To find the resultant force, we will use the parallelogram law. Now, there are two steps in this parallelogram law. Step number 1 is we need to create a parallelogram using the two forces. So, for example, if I draw dotted lines so as to create a parallelogram, incidentally, in this case, the parallelogram is a rectangle only. Step 1 is to create the parallelogram. Step number 2 is to draw the diagonal like this. And this diagonal will represent the net force. And let's say the net force is at an angle of alpha with the 6 Newton force. So let me summarize. What is parallelogram law? According to this law, the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram. But we are supposed to find the magnitude of the net force as well as the angle alpha. So how do we do that? Since the two forces are perpendicular to each other, we can very easily use the Pythagoras theorem, which is square root of a square plus b square. In this case, a is 6, b is 4. So the magnitude of the net force will be square root of 6 square plus 4 square, which will come out as approximately 7.21 newtons. In order to find alpha, we will use basic trigonometry. So we can either use sine alpha, cos alpha, or tan alpha. So let me use tan alpha. Tan alpha, if you remember, is opposite upon base. So the side which is opposite to alpha is this length. And length of the side is nothing but 4 newtons. So tan alpha will be 4 divided by base, which is 6. So tan alpha gives us 4 upon 6. And then if we take the inverse of it, we can easily find the value of alpha. And this is how we figure out the net force when the angle between the vectors is 90 degrees. Now let us consider a situation when. Let's read this. If the angle between the vectors is neither 0 nor 180 nor it is 90 degrees, what do we do in that case? So here we can see the angle is neither 0 nor 180 nor 90 degrees. When the angle was 0 degrees, for resultant we added the two vectors. For 180 we subtracted the vectors, and for 90 degrees we use the Pythagoras theorem. But what do we do in this case? We are going to apply the same parallelogram law. Step number 1 was to create a parallelogram like this using the two vectors. Step number 2 was to draw the diagonal, and this diagonal represents the net force. Now let me consider a specific situation when the angle theta is 30 degrees. So in this case, how are we supposed to find the magnitude as well as the direction of the net force? To do this, we have to learn something called resolving of vectors. Resolving vectors basically means there will be a vector which we need to break into the two components. Let me explain.